It works. Great. Good afternoon, everyone. Warm welcome to all of you to this plenary session. Thank you very much for your interest and also for being here and finding Hall D. I'm honored to moderate this session, which, as the title states, will provide an outlook for ESA's Earth observation programs. This outlook will be, on the one hand, rather short-term, because it will really focus on the program proposals that ESA is putting on the table at the next Ministerial Council meeting in November. But by the very nature of ESA's Earth observation programs, this outlook is also very long-term, because many of the programs that we will be putting on the table now are for missions that will be flying many years from now. But regardless of what time frame we're talking about, the nature of this session is really one of an overview. There have been several sessions already today on the outlook for the Copernicus program. There was also a session on truths, which is one of the programs that you will be hearing about during this session. And later in the week, there will be opportunities to learn even more about several of our other programs, including Future EO and Digital Twin Earth. So the way we've structured the session is that we will first hear from our Director General, Joseph Aschbacher, who will give us an overall context of the ministerial and where the Earth observation programs fit into the overall agency's activities. Second, we'll hear from Simona Tekeli, the Director of Earth observation programs, and she will give an overview of the programs that are being proposed, but also a more focused look at the context in which the Earth observation programs and Earth observation sector find itself in right now. Third, we'll hear from Charles Galland, who is a policy manager at Eurospace, the trade association of European space industry, and he will be providing some remarks that are coming from a position paper that was released several months ago by Eurospace, giving ESA and the wider community some thoughts on what we plan to propose at the Ministerial for Earth observation. And finally, we'll hear from Professor Andy Shepard. And while we would not dream of asking him to represent the entire scientific community, because of his long experience with ESA, its missions, and its programs, we're really pleased that he has agreed to provide some of his thoughts from this experience to share with us and the audience. So without further ado, I will invite the Director General, Joseph Aschbacher, to give his presentation.
So thank you, Eleni, and also very warm welcome from my side. You have actually already seen the second slide. But before I go into it, just a couple of words on the ministerial preparations, how it works, and of course then we focus on Earth observation, how the Earth observation package is part of the overall ministerial package. 3 years ago, we had the last ministerial conference in 2022, and when I prepared, it was my very first one as Director General to prepare the ministerial conference, which is always a very important milestone for Europe and obviously for ESA. I was faced with a number of issues, a number of challenges. There were actually 3 of them. And people said, look, under these conditions, the ministerial will be very tough to organize. Number one, we just came out, or Europe just came out from the COVID crisis, which, of course, was a strain on many of us, including the economy. Number two, Putin marched into Ukraine, so we had a war on the European territory, and again, everyone was concerned about safety, security of people. And number three, many countries in Europe had double-digit inflation rates, 10%, 12%, or some of them even more, meaning that the economy was uncertain. This was mid-2022, and some of you remember very well when people did not know what happens to the economy and can we afford future investments in space or in anything, and therefore it was not good boundary conditions. So people came to me and said, look, under these conditions, the ambition for the ministerial conference has to be low, because we will not be able to provide funding, we will not be able to support all the new programs and activities, and therefore they really advised me to have a lower figure and a lower budget to be proposed. I did not listen, I shouldn't say that, but I didn't listen too well, and I kept the ambition high. I also see this as my job as Director General to have an ambitious program, and then obviously I rather fail on being too ambitious than succeed and not being ambitious. And that I think is something very important to recall and to do. And the result, you know, I don't need to repeat what the result of the ministerial was. We got a record funding for the programs of ESA across the board, 17 billion, 17% more than the 3 years before, plus inflation, because our programs are calling inflation as we go into implementation, so inflation is added afterwards. So actually the increase was obviously more in real terms than the 17%. This time, I'm facing a very similar situation because I'm discussing and preparing the ministerial package with my member states, and some of them are here in the audience, and really would like to acknowledge and be grateful of all the advice and the advice and the input I get from all the member states. But we are facing a similar situation. On one side, I think it is crystal clear that we need to raise our ambition for many reasons. On one side, the economy, the space economy is growing, and is growing very fast. All of you use the same figures which we are publishing. The space economy today is about 500 billion euros or dollars large. It is growing to 1.8 trillion in the next decade. That means if you just extrapolate in a simplified way linearly, it's roughly a growth of about 9 to 10% per year. So it's a very fast-growing segment of the economy. Any growth of 10% is very attractive, whether this is energy, space, or anything else. So therefore, from an economic perspective, it's a sector in the economy that is growing very fast. That alone is already very attractive. In addition, of course, we are delivering services for citizens every single day, and especially Earth observation is doing a lot of it, because we deliver services for farmers, for health practitioners, for city planners, for forest people, for aviation, for disaster management people, to provide information in case of crisis, and for security. And this is something where we deliver information, data, services for citizens, which are, of course, crucial. And then the third reason that came only very recently is that we have a geopolitical situation where Europe is asked to stand on its own feet much stronger. In defense, we see exactly what happens. The NATO summit is happening right now as we speak. Budgets are increased on defense to the level of 5% of GDP. And space is part of defense, is part of security of people. And therefore also in space, we have to increase our independence, our autonomy, our strength of Europe, not to isolate ourselves, but to be a good partner, a strong partner to the international community. And these three reasons for me are really a good reason why we should increase budgets in space, budgets in Europe, because we have to catch up and we have to really use space to the best possible way for people and citizens. And for this reason, I'm putting together with my team in Earth observation and all the other directorates in ESA, are obviously always in very close interaction and based on advice from the member states, an ambitious package, an ambitious one. But sometimes I hear that it's too ambitious, it's too much money, because also the economic situation is not an easy one. And I know perfectly well that in many countries, including this one here or many other countries, there are budget plans that need to reduce the spending of a government in order to make sure that you, on one side, have to cope with the budget situation of a country. On the other side, I see the attractiveness of space is going up. So there we have to find the balance, I hope on the upper side rather than the lower side. But this is exactly what happens right now as we speak and prepare this ministerial package. So this is a bit the bigger picture we are facing in Europe for all of space. And then obviously you have to break it down segment by segment, Earth observation, exploration, telecom, navigation, and many other things in order to then define content to the best possible way. So I'm giving you a little bit of an overview and the context. Simonetta will then go very deep into the Earth observation package, so I will give you the much broader view. ESA, I think I don't need to introduce to you, you know ESA very well. Maybe just to recall some of the points which are significant. Maybe the middle figure is the most important one, that ESA is implementing or is spending about 60% of the public funding in space in Europe. The other 40% are being spent by European Commission, by USPR, by EUMETSAT, by national space agencies. So in other words, what we do, what we propose as European Space Agency is certainly a very important direction that we put on the road, because this will define some of the major programs for space for years to come in Europe. Of course, we do this not in isolation. We do this with our partners, European Commission on one side, always with the member states on being and guiding us for all the elements we do. But this gives you the order of magnitude of how we implement activities. Europe has developed a lot of excellent programs. I don't need to recall them. You hear them in this conference here in the Living Planet Symposium in many domains. You hear, of course, here the ones that are related to Earth observation. I know them personally very well. As you know, I've been in Earth observation for most of my career, in the last position as Director of Earth Observation. But let me focus a bit more widely of what ESA is doing, what we're doing in space in many domains. Of course, we develop rockets. Access to space is fundamental. Last year, we had a very important milestone of having the first launch of Ariane 6, a very important milestone, together with the return to flight of Vega C. That means we have the rockets we need in order to bring satellites up into space, and therefore those satellites delivering data. Generically, we are delivering and we're developing technology. That means we are going from low TRL levels to higher TRL levels. We are taking the pulse of our planet. I'm not elaborating on this because you know it well. Galileo, a very important system providing very high accuracy navigation signals. And of course, we have many other programs where we work together with our partners internationally and within Europe. I've shown this slide on the first day already, but I would like to recall it because it is such an important message I'm using also in the preparation of the ministerial. This is showing the investments of governments in space globally. And you see that today we have a global space budget of about 100 billion, meaning that the spendings of NASA, of the Space Force, of ESA, of JAXA, and many other space agencies, if you add it all up, it's 100 billion, of which in the United States about 60%, 61% are allocated or spent. Europe has a share of 10%. And this is something which, of course, we look as European Space Agency into it and see whether this is a good share or a share that needs to be changed or increased. And you can imagine what I say to my member states. If you want to really develop and utilize space technologies to the maximum possible for our citizens, all the service that we provide, that we are discussing in the Living Planet Symposium, but also all the other space activities, we need to raise our share from 10% to something much higher, because we have the capacity, we have the people, we have the excellence, we have the engineers, we have the scientists, we have all the elements that are needed to do that. And this is the argument which I make to my member states in order to tell them that this is something that is not good, that we have only 10% of the global share. Of course, we're also reinforcing our partnerships with our partners globally, NASA obviously being our long-term partnership and partner for many activities. We have built missions together. We have gone through hard times and good times together with NASA. Of course, now the budget situation is challenging, and we are working together with our US partners and see what this means for Earth observation, but also exploration and science missions, but certainly something that has been a long-term partnership which we had together. But also other space agencies, Canada, Japan, India, South Korea, Australia, and many, many more are working with us, and we are working with them. This is something that ESA is actually quite well known for, that we do have many cooperation agreements, many partnerships with our respected partners. We love to be one good partner in a partnership, in a cooperation, because this is exactly what we need to do. Space is so demanding, is so challenging, that we really need to stick our heads together and make it work. One word about the Space Strategy 2040, which we published just recently. And this is something that is a very important guideline for the long-term future. Based on this ESA Strategy 2040, there are also strategies that have been developed for Earth science, and Simonetta will probably explain the Earth observation science strategy. We have another one for exploration, where the exploration activities, that means exploration of Moon, Mars, and low Earth orbit are being described in much more detail. We have a technology strategy of which technologies are required in order to get to this longer-term strategy. But this really, the overarching one is the ESA 2040 strategy, which has those headlines or those goals, as we call them. And I go through them a bit one by one to give you the context of what is on the menu for the ministerial, because the ministerial package is organized along these headlines, along these goals of the 2040 strategy. First one, protect our planet and climate. This is very much geared to Earth observation, but not only. I'm not explaining the Earth observation part, because Simonetta will do this in detail as part of her presentation of which elements in Earth observation will be element of goal 1 in protecting our planet. But also we have other elements like protecting the planet from asteroids, protecting our planet in terms of space debris, in-orbit servicing, sustainable usage of our outer space, space weather, which is something that, of course, is also part of sustainability in order to protect our planet. An interesting one is planetary defense. We have launched just recently, a few months ago, Hera, which is a spacecraft that flies to Dimorphos and Didymos, which is a pair of an asteroid, which was hit by the DART mission of NASA. And what we are doing with our satellite is to observe how this impact, kinetic impact, was changing the asteroid themselves, Dimorphos in particular, and how the pair, that means these two asteroids, one rotates around the other one, have changed their cycle. Our prediction was that this impact would change the orbit of Dimorphos by about 3 minutes. The reality is that this orbit has changed by almost half an hour. So that means our prediction was not correct, meaning that we have not fully understood how this asteroid is made of, how the impact has changed its behavior. We know there's a crater, how deep it is and whether this has cracked open the asteroid, we do not know, and that's why we fly there. We investigate exactly with the Hera mission and 2 satellites or 2 landers that go down and measure from a closer distance, but also land on the asteroid to understand much better how asteroids function, because this is exactly what we want to look at. In case an asteroid comes to us, towards planet Earth, what do we need to do in order to protect ourselves? That means our planet, eventually having different measures that are necessary to avoid an impact. There is an asteroid coming towards us, not hitting planet Earth. I can reassure you, you can have a quiet party tonight. But on Friday the 13th, 2029, April, there will be an asteroid coming towards our planet Earth. It will actually come close within the arc of the geostationary satellites. That means inside the 35,800 kilometer arc, will fly over Europe towards Africa and then leave again and go out into outer space again, thank God. But we have just last year decided another mission called Ramses that will be built right now, will be launched in 2028 in order to encounter this other asteroid called Apophis that comes in 2029 to us. It will be very spectacular. You can see it with your naked eye. There will be lots of attention, as you can imagine, when this asteroid comes towards planet Earth on Friday the 13th. Certainly something where we will have a satellite mission ready to look into. Of course, protecting our planet and climate, this is a lot of Earth observation. As I said, Simonetta will go into it, but this is certainly something which is the number one, or which is one of the goals of our strategy 2040, and therefore also a very strong package in the ministerial package of towards the ministerial. Maybe just as a footnote, I said it at the opening on Monday, that today the ESA budget, which you have seen is about 7.7 billion, 30%, actually a bit more than 30%, is allocated to Earth observation. Copernicus, Galileo, Earth Explorers, and all the programs around it, including science and data utilization. This is by far the largest portion of investments within the ESA member states, which is geared towards Earth observation. Explore and discover. This is the second goal of the strategy 2040. Again, future EO, that means Earth observation is very prominently featuring there. I will leave the explanation and all the details to Simonetta to explain, and I will focus a bit on the universe and the and the other elements which are dealing with the Moon, Mars, and low Earth orbit. On the universe, of course, exploration, explore, and discover also means that we use our space science missions to really look into the universe. Today we have some fascinating missions. Gaia was just taking measurements of the Milky Way. Sometimes we call it, this is the Google of Milky Way, with billions of objects that have been mapped, and scientists across the globe are working on this data to really retrieve and understand much better our Milky Way surrounding. But also we have JUICE launched about 2 years ago, a mission that goes to the Jupiter icy moon to see whether those icy moons are habitable in principle. That means whether the conditions are right that life could exist on one of these icy moons. And this is a very fascinating mission. If you talk to astrobiologists, they would tell you, if you look for traces of life or maybe real life in the solar system, go to either Mars or go to the icy moons. The icy moons, as you know, have huge oceans under a thick ice cover. The ice cover is up to 100 kilometers thick. The oceans, some of the larger icy moons have more water on these icy moons than we have water on planet Earth, so enormous amounts of water. And astrobiologists say under the ice cover, protected from cosmic radiation, there might be forms of life, of course, not seeing light, but having very severe conditions, and there might be some form of life or nothing, we do not know. And this JUICE mission actually is exploring the habitability, not life. We're not digging into the ice cover and going into the ocean, but we see whether the conditions would be favorable for life and how the structure of these icy moons is done. If the answer is yes, that means we believe that there could be life existing there. Of course, the next step would be to fly a mission to one of these icy moons and actually land on it, take a probe and do that. In fact, this is one of the plans we have right now, to have a future mission going towards Enceladus, which is very far away, even further away than Jupiter is a moon on Saturn. And this would just take 10 years to get there, and then obviously if you go there. Another destination, so what we have in terms of our package as the science program, we have Ariel, LISA, New Athena as the main missions that will explore some of these, I would say, secrets of our universe and to understand some of the big questions of where are we in the wide universe, where do we go, how does it expand, we know that it expands faster, so that it's not a linear expansion, but there's an acceleration, which means there's a dark energy that is pushing our universe out and accelerates it. This is also a mission which we launched about 1.5 years ago, Euclid, which looks into exactly that, to understand how dark energy, dark matter function, and in order to do that. The next ones in line are these three, as I mentioned, Ariel, LISA, and New Athena, again, to answer some of the big questions of our universe. On the right-hand side, you see the exploration part from the Human and Robotic Exploration Directorate. We have 3 destinations we are focusing on. Low Earth orbit, that means the space station today, and after the end of the space station at the end of this decade will be commercial space stations. All this is in evolution and development right now, but certainly ESA is shaping it significantly. Moon, obviously being the next destination with robotic exploration, but eventually also with humans. There, of course, there's a lot of activities ongoing. And Mars, also where we have a very important mission planned, which is called Rosalind Franklin. Again, I mentioned before that if you look for traces of life or some sorts of light outside this planet here, go to Mars or go to the icy moons. And on Mars, we will be the first ones to drill into the Mars surface and analyze 2 meters underground, that means from the Mars surface samples, and see whether there are traces of previous lives or maybe still existing lives that could be found. And this is quite a challenging mission, as you can imagine. Nobody else in the world has such a similar mission. The Mars Sample Return mission, which NASA was proposing, is now proposed to be cancelled. So this will really be a mission that looks into traces of life there. Just imagine for a moment, either on Enceladus or on the icy moon of Jupiter or on Mars, if we do find traces of life. If these traces of life or this form of life, of course we would look whether they have a structure like we humans, a DNA. If this life would have a DNA, that means we have a common origin. And we are one of a species that is probably spreading across the universe. If they don't have a DNA, or not the DNA as we have it, then there are different sources of life. So you can imagine what all this means for our understanding, our existence, and there's so many things that are impacted by that. And so this is something that we're looking at under Explore and Discover, which is certainly a very fascinating activity that we have. Goal number 3, strengthening European autonomy and resilience. This has really to do with making Europe stronger. This is a new goal in the sense that we really put emphasis on Europe being a stronger, more independent, more autonomous partner, and with our own capacity that we are building up. It starts with access to space. That means our rockets that we need in order to bring satellites into space. In addition to Ariane 6 and Vega C, we are developing a new generation of rockets through the European Launcher Challenge. There will be small launchers at the beginning, launching a few hundreds of kilograms, maybe 1,000 kilograms, and eventually become a heavy launcher. But we do it very differently, because as ESA, I would not like to develop the successor of Ariane 6 to be an ESA-developed launcher, Ariane 7. I would like the successor of Ariane 6 to be a launcher where I am a customer, and as well as the European Commission or other public entities, an anchor customer where I can say I buy 10 launches from you, and you, private company, you develop the best launcher you think is fit for your purpose, with your partners you choose, with your technology that you choose, in order for us to be sure that we can buy this service and therefore allow you to really develop and build up. So this is certainly one of the elements of autonomy. It's not only the launchers, it's the whole infrastructure in space. There will be fueling stations in space. There will be other activities that make sure that our guaranteed access to space is guaranteed. The other part of autonomy and resilience, certainly again Earth observation. I will skip over this slide because this will be explained by Simonetta. But there's one I really would like to mention, which is called ERS. ERS may be sounding familiar to some of you in the room here, and we have very, very well chosen this acronym. But in this case, it stands for European Resilience from Space. European Resilience from Space, as the name indicates, is a program that I have proposed just recently, based on input or discussions with our member states, who said to me, we need to build up our own resilience. We have to get stronger. We need to have technology that we do not have today, or infrastructure we do not have today. And in this particular case, it is very much linked to Earth observation, because we do need in Europe, and this comes from the security players with the European Commission, having a commissioner for defense and space, telling us that we need a very frequent observation constellation that gives images every 30 minutes or so, very high resolution optical, very high resolution radar of any place in the world, and making sure that we do know what happens in different places for security, for resilience, for different purposes, also obviously to support the defense and space ambitions of the European Commission. And this is quite a game changer, because we know how to do it. And this is exactly here at the Living Planet Symposium, where I don't need to convince you that we have the technology, we know how to build spacecraft of excellent quality, but where we are not yet good at is having large numbers. That means constellations of hundreds of satellites in order to make sure that we have a very high density, very high observation frequency, obviously with AI on board, obviously with computing on board, with interlinked systems, secure communication, navigation linked to it. So it's a system of systems in order to build up this capacity. And that is new. That does not exist today. And that is something that is really underlining the autonomy that Europe needs in order to really support also defense and security actors across Europe. Another goal is goal number 4, boosting commercialization and growth. That means the commercial aspects of space. Again, in Earth observation, there's many of it that is happening here. But also we have a very strong business incubation network. We have an ESA investors network that we created. I'll just give you one number to underline a bit the effort that we have undertaken the last few years. When I became Director General 4 years ago, I declared commercialization as a priority, which I really would like to build up. So we have created, for example, an ESA investors network where we enter into partnerships with venture capital companies, with funding entities, in order to attract funding to businesses, to companies that are needing funding, but also that are building up services that are more mature and therefore making business and making money out of it. We had 3% of the global commercial share of the private investment in 2019, 3%. We have 22% today. Last year we had 1.5 billion of private money flowing in from venture capital companies into Europe, into our companies, in order to really match our excellence in technology with the funding opportunities, and therefore create lots of opportunities across the board. Last but not least, Inspire Europe. This is one of the goals of our strategy, and I think that's the most beautiful one, because there you really put all the technologies together that we are developing, from Earth observation to astronauts to different exploration activities, because space is so fascinating, is so inspiring, and this is certainly something where we would like to put emphasis, that we do it together with all of you, together with industry, together with school classes, together with the educational system, together with astronauts, in order to make sure that what we do is really explained well to politicians, to the citizens, to the young kids, to the older adults, to really make sure that we value and we show what space can do for Europe and for the world. So thank you for your attention.
So, ladies and gentlemen, good afternoon. You now know the overview of everything that's going to be presented at the Ministerial from my Director General. I'm going to try and go a little bit more in depth into the specifics of the Earth observation program, giving you the context and the content of those proposals. But before we do that, I wanted to give you two figures. I've displayed them already yesterday at the opening plenary, but it gives you an idea of the trend. They're expected about 5,000 satellites in Earth observation to be built worldwide until 2031. That's a trend in terms of numbers associated to the space segment. And another number, which is the one associated to the value-added sector, is related to a growth of about 10 to 12% expected on the value-added sector products and services in this domain. So strong economic perspective. There's also another element that was also displayed by my DG, about 15 euros per person spent today through ESA in terms of total investment. So the need to be staying competitive, the need to invest more, the need is also mentioned by the Draghi report recently, by von der Leyen report on competitiveness compass, but it's certainly something that's very relevant also in space and in Earth observation. Today, we have a program that is delivering, and that's very important for the Ministerial, where actually member states are looking at how to invest when, at what time, with which amounts. So a long-term planning that reflects really the needs in terms of spending and in terms of capacity of industry to absorb what is the investment that we do is very important. And just to mention, we really did 5 satellite launch in Earth observation in the various domains last year, all successfully. Also thank you to the teams, but to the industry support, to the way those projects were developed. And this year we have 11 launches. By the way, last night 7 satellites were launched from the National IRDIDE Italian program, and we have next week planned launch of MTGS together with EUMETSAT. So really important to deliver on what member states will invest, and also really important to have a long-term plan that fits to what is proposed. Today, this is the program, the Earth observation program as it is, with the 3 lines, the meteorological one that we developed together with EUMETSAT. That's not part of the ministerial package this time. Then you have Copernicus, which is part of the ministerial package, jointly with the Commission, with a long-term scenario, with co-funding from ESA at the ministerials and the MFF from the EU side, with 4 satellites, by the way, still to be launched on the Copernicus family this year. Last but not least, very relevant for the ministerial, you have the science mission, the Earth Explorer. You've seen yesterday the first image of Myomas. That's an Earth Explorer mission, a scientific one, which is done to respond to scientific objectives, but also to societal challenges, and also to contribute to really things like climate change. So very relevant Explorer missions that are also part of what we would like to propose for ministerial. The budget was mentioned by Joseph. Today, Earth observation corresponds to about 30% of ESA total budget in 2025. This is just because of the recognition made by member states of the relevance, political but also programmatic, of this domain. So Green Agenda, as you know, a few years ago, very top on the priorities of the European member states of EU, climate challenges, extreme weather events, need to better manage natural resources. This is why this program is today so, I would say, sizable, and we hope that it will stay there also for the next ministerial. We got some mandate from our member states. We were told at the last summit, which was in 2022 in Sevilla, please don't just build satellites, also valorize the wealth of the EO data that you do have available. And today we have a value, which is the big data, of course, coming out of all the missions that you've seen, the 16 in operation, but the 40 that we're actually in the making with everybody and with industry in Europe. So use those data sets also in the context of what ESA should do in terms of applications, in terms of demonstration, in terms of also integration of AI technologies into that sector. And this was also a really strong message that came out from the Space Council, from European Union and ESA member states last year in May. So what's the rationale of our program proposal? On one side is to keep the science excellence. This is certainly part of what we do in terms of core DNA of what ESA does. Science excellence is really what we've been always doing, not just with Earth observation missions, but also with science mission. And this is an ambition that we have further to develop for the ministerial in 25 in EO. We also, as I said, need to valorize the data sets that we have. Make sure the data are used. They're not just build the satellites and then put somewhere, but really better have a valorization, a use by users and potential users of those data sets, which are relevant for domains like energy, environment, climate, sustainable resources, agriculture, and you name it. Even many sectors like private sector, for example, the insurance sector. We also want to support the competitiveness of industry. This is one of the objectives that Joseph showed, and we do actually reflect that objective also in the Earth observation package proposal, particularly with some elements of that proposal, in particular a program that I'll tell you in a minute, which is called InCubed. And last but not least, we want to have space solution in support to policy implementation. There, we're really working very closely, very hard in support not just of the Environmental Convention of the UN, Ramsar, desertification, climate, but really teaming up with the European Union, with DG Clima, to provide demonstration, R&D products, services of solutions that come from EO data and space data in support of implementation of those policies. That's the rationale in which we have discussed, built, and consolidated the EO domain of the DG proposal in the last few months. We've discussed this very much with member states. We are continuing to do that in the coming months. We've also discussed it with industry. We presented those proposals recently in ESTEC at the Industry Day. And of course, we want to have it here as a showcase, as Living Planet includes everybody, scientists, industry, and key players from member states and institutions. So what do we have in the package? We were told and really instructed to try and give less program lines to ministers to choose. Last time, there were lots of programmatic lines, too many options maybe for the table for decision makers to understand really the value of one or the other programmatic line. So we tried to really go into that direction, and we have reduced 7 program lines that were at the last ministerial into 5 programmatic lines. And this is on one side a success for now, but challenging at the same time. In fact, FutureO, which is the core program proposal going on the table for ministers, is today including also 2 previous programmatic elements. One is the climate space, which is all what we were doing about supporting the 27 climate variables in the context of UNFCCC. And the other program is the GDA, Global Development Assistance, which is a program that was built and it's currently still implemented in support of companies' perspective and application into global assistance, so in regions like Africa, Latin America, and Southeast Asia. Those 2 programs were integrated into FutureO. That makes FutureO quite ambitious, but also quite challenging in terms of volume. And also, this is a program which is an envelope program, which I'd like to say is already subscribed by all 23 member states of ESA, so really a success story. But it's a program that, being an envelope, has various elements that, of course, need to be maintained if we want the coherence of the program. It's a program that also allows flexibility. So in the past, we could use this flexibility of FutureO to rebuild missions when we had a situation of, for example, of Cryosat, an Explorer mission. In 3 months, it was decided to rebuild it. And here I see Andy, who will tell you all about it. Just to tell you, in FutureO, what do we have? We have elements of foundation, which means TRL increase for companies, technology developments, preparatory studies of future mission, not just scientific mission, but also operational meteorological mission and Copernicus. So very relevant preparatory activities in that domain, frequency management activities, and all what is needed to prepare for the future. We also have the development of Earth observation mission, and there we plan to complete a mission called Harmony that was initially funded at the last ministerial. It's a mission that looks really at interferometry, but also at oceans, with a radar on board. Very important mission, I would say, for the scientific context, but also for the application domain. And we plan to select, before the ministerial, the Earth Explorer 11. So another science mission of envergure. There are 2 shortlisted. We have a user science community meeting planned in Prague in July. We have an ASEO, which is the Advisory Committee on Science for ESA meeting, and the program board will shortlist one of these 2 Explorer missions. And those are really highlight missions, as you've seen yesterday with the ERCA results or the biomass one. And then we have a mission which is called Opportunity Mission. It's NGGM. It's a gravity mission. It's a follow-up of the previous Explorer Gauche mission. It's in collaboration with NASA, and I just had a meeting with my NASA counterpart where the hardware collaboration is not existing, so not at risk in this current context of potential budget cuts, but really the science collaboration between the Grace C mission developed between Germany and the US and this NGGM mission developed by Europe is maintained and will be enhancing the value of this precision measurements of that mission, which is on ocean circulation and will support climate. We have more scouts. These are small science missions. We will launch the first scout by the end of the year, Hydrogenesis. We have had a call for the next scout mission. We have shortlisted 4, and we plan to fund, of course, 2 more with FutureO, provided it's fully funded. And last but not least, in FutureO, this element of Earth action, which is now becoming a very important element of not just building the satellites, not just developing the mission, preparing for the future mission, but also organizing the data sets, doing value-added products, demonstration projects, collaborating with the scientists in the context of open science, and also working on products and services that can support requirements by concrete users. And there we're looking at methane demonstration, we're looking at greenhouse gases, products development, we're looking at agriculture, precision farming, all what is really relevant in the context of application. But it's not just pure research. It's research providing those sector value-added companies perspective for commercial exploitation in the future. We have continuity of Copernicus. This is a program in terms of content that was already decided in the past. It includes Sentinel-2 and Sentinel-3 next generation. And then we have Truth, a mission yesterday. Some of you might have been at the dedicated session. That's a mission which is a meteorology mission in space, first time, will support the calibration of future mission in Earth observation, also of commercial missions, by the way. Incubed, to support startups, technology, good ideas in SMEs, good ideas in the value-added sector. Last but not least, the continuation of Digital Twin, which is a project that we do in collaboration with the European Commission. Destiny is the corresponding one, in terms of having prediction capabilities, forecasting capabilities, using AI and integrating that into all what we do. And here is what I just told you. I don't need to dwell into that. You'll find everything in the slides that will be distributed, so you'll find really the details of what we do in terms of preparation of future mission, generic technologies development, frequency management on the foundation, the missions that we plan to develop. The Earth Explorer mission are Wyvern and Kite. They'll be shortlisted, as I said before, ministerial. And of course, this will complement the science gaps and science objective that we've talked about in the science strategy. But the climate change is still there, as I said yesterday, so climate action is part of Future Rio. Global Development Assistance will continue to be the work that we do with the World Bank, the Asian Development Bank, in enhancing products and value-added EO sector. And this is the other programs I just mentioned with the Copernicus, with Sentinel-2, Sentinel-3 next generation optical, continuity of the current systems, truths, InCubed, and digital twins. And on that, I must say that we have details again of all the program proposals. We're all available here. There are dedicated sessions all during this week on the specific program proposals. So I suggest you go to those where you have all my colleague experts and they can elaborate further on all of those. Truth was actually yesterday. I think it was a very comprehensive session that explained very well the proposal and the next steps. And the digital twin certainly, it's something new in the domain of Earth observation, was started a few years ago. It's something where we just try to integrate new dimensions of this sector, not just the traditional EO one, but including AI, integrating AI, machine learning, computing capabilities into the traditional Earth observation sector. And InCubed again, here with some details. The PhilLab colleagues are here. There is even a stand area where you can find them, get all about it. But just to mention, I think there is also a current geopolitical context that is changing. There's an increase, as you heard from my DG, of the relevance of space in support to resilience, in support of security needs, defense needs. And there is also geopolitical context where maybe Earth observation can be a further opportunity to increase overall together, not just at ESA level, the European leading role that we have in this sector on climate, on sustainability. And the current proposals are really going into that direction. So I wanted to mention also that opportunity in the context of what we are proposing. Last slide, it's on ERS. I think Joseph mentioned it and explained it very well. It's a new program proposal. It's an optional program. We are currently consolidating the proposal in the context of the Program Board of Earth Observation. We have an industry day planned next week in ESTEC, where actually Eurospace and new industry will be invited. We are discussing with member states how and what we can, shape this program, what is also be able to be supported without putting in danger the really good program package that it's the existing one in EO. The ambition is actually also to get additional funds from the Defense Authority in the context of this program. It's also to work very closely with the Commission, and we are really working on a work plan in terms of having this as an enabler of a longer-term perspective of what is called the OGS in the European Commission side. We're also working on clusters, few countries that are called Coalition of the Willing, who are willing to develop initial systems in support of dual-use autonomy of Europe. And with that, I tried to be fast, but also to give you a feeling of what the proposals are for Earth observation. I'm available all this week, so are my colleagues, and we can certainly continue the dialogue on this through Program Board, of course, with member states, with the industry in the right fora, but also with you all attending the Living Planet Symposium. So thank you.
Dear Mr. Aschbacher, dear Ms. Kelly, dear Mr. Shepard, Eleni. So my name is Charles Galland. I'm working for Eurospace. Eurospace is the trade association of the European upstream industry. So it's a non-profit organization which was created in 1961. So our members are companies, upstream companies that are active in design, development, and integration of space systems. So today our companies, they represent a bit more than 60% of total industry employment and a bit more than 90% of final sales. And our aim is to foster the development of space activities in Europe and also promote a better understanding of industry current challenges and issues. So what was presented now is not a surprise for industry. As Simonetta said, we were presented those proposals in December in ESTEC, but also in early April in ESTEC as well. Based on those proposals and those presentations, we issued a position paper, which was released in April and which is available on our website, so eurospace.org. And the content of my speech today will be largely based on the position paper that was produced by industry. So we are at crossroads. The European Earth observation programs that ESA will present in November are not just technical proposals, they are decisive policy instruments. Instruments that will shape whether our industry will remain globally competitive or fall behind. So ESA is and must continue to be a strategic partner for industry, but we also have a clear and direct message. We need a program that enables us to move faster, compete harder, and innovate more freely, and I think what will be proposed in November will enable that. So why Earth observation matters for the upstream industry? So Earth observation is not just about science, it's a market and a central asset for the European space supply chain. So indeed, ESA has provided one of the largest growth opportunity for European space systems, worth 4 billion of industry sales in the past decades, and supported the development of a supply chain which is spreading throughout all ESA member states. So, and beyond the numbers, and it was also said today, EO is becoming central to Europe's strategic autonomy. The war in Ukraine, climate-driven disasters, tensions over critical supply chains, these aren't abstract problems, they are real, immediate challenges. So space-based EOs systems offer unique capabilities that no other infrastructure can provide: global, persistent, secure, and independent access to intelligence and insights. But these systems, they don't buy themselves. They rely on sustained industrial capacity, on technological leadership, and on investment cycles that are far longer than a single program. That's why continuity matters and why the upcoming ESA EO program must be built with long-term industrial strategy in mind. And for industry, the Earth observation programs is a structuring program for the European space sector. So what ESA must deliver to enable industry? So ESA has a key role for industry. It's not just to initiate missions, but it's also to create the conditions for industry to thrive. In this regard, the European space industry is strongly convinced that the renewed ambitions put forward by the Directorate of Earth Observation for the next CMIN will allow Europe to further strengthen its Earth observations assets in support to the traditional and emerging need of European member states and citizens, with the dynamic commitment of ESA member states. And the upcoming Earth observation packages includes many strong elements. Maybe just quote me three. I will just quote three of them. So the first one is the proposals. They are promoting schemes that support industry competitiveness. For example, with activities contributing to demonstrate the value of Earth observation, with the integration of digital technologies, the risking activities, and procurement of activities that are relevant also for the security and defense sector. Second element, the package, and in particular Futurio, is contributing to a much needed de-risking of activities for industry. It also includes the development of dual-use technology that are timely and relevant today. The proposals also support the development of projects that have a commercial potential and that could open new market opportunities for the European space industry. And third element, the European space industry also welcomes the potential of the program to have a multiplier effect, not only by preparing activities for operational mission like in meteorology or Copernicus, but also through the science missions and the Futurio, for example, the Earth Explorers, that could become operational ones in the future. So these are the right ingredients. And from our perspective as industry, it's essential that ESA-EO programs, beside their value for Earth science, enable as much as possible as well market-oriented innovations. So if we get this right, we can turn ESA investment into global industrial leadership. If we miss this window, others will fill the gap. Because today we are evolving in a new Earth observation landscape. It is not what it was 5 years ago. We now operate in a world of smaller satellites, rapid iteration, service-based models, and mixed civil-military applications. National Earth observation delegations are being deployed across several member states and in the industry as well. So it is undergoing rapid technological transformation with advancement in real-time data processing and constellation deployment. These innovations are shaping the future of Earth observation missions, improving efficiency, reducing costs, and expanding the range of applications. And ESA programs, they must adapt to this reality. So we need ESA to support constellation development with real industrial scalability. That means funding not just the satellites, but also the system integration, the ground segment, and the service layer. We need stronger support for full mission concepts, not just technologies, and this will be essential to attract private investment. And we need also ESA to be a much more agile procurement partner, supporting serial production, standardized platforms, and interoperable architectures. Without this, European companies, they cannot compete against US or Chinese players operating at industrial scale with consistent anchor demand. So in summary, the ESA EO program is not just a technical proposal, it's a strategic investment in Europe's industrial future. ESA must remain a scientific and technical leader, but also increasingly become an economic and market enabler. And the European space industry is ready for that. We are growing and actively preparing to absorb increased funding and workload with the agility to adapt rapidly to market expectations. And by providing a critical mass of activities, ESA programs will be key in fostering the robustness of the European space industry and supporting its further industrialization, scalability, and ability to deliver at pace and volume. So let's use CM25 not only to support excellent missions, but also to make ESA the engine of European Earth observation industrial leadership in space. Thank you.
Thanks a lot, Charles. And now we move to Professor Shepard.
Thank you. Okay.
It's ready to roll?
It's ready to roll.
Okay.
Thanks very much. So I'm really pleased to be here today. I don't represent all of the science community, but I have worked alongside ESA for a long time now, and they've supported a great deal of the work that you'll see in this presentation. I'm going to talk about Earth observation in support of science, how important it is in support of science, climate science in particular, and then action by us and then other people. So it's not just important for the science community, it's important for a much, much broader community. And it starts in the 1990s, when my career in Earth observation started. Charles probably doesn't remember this, but I'm sure Simonetta and Joseph do. Take your favourite. Because the 1990s was a really important decade, not just for music, but for other things as well. It was the start of the Intergovernmental Panel on Climate Change. So the first two assessment reports came out in the 1990s. This is the second one, 1995. And in it, there were some cartoons about what would happen to Earth's polar regions in a warming climate. And back in the 1990s, the science believed that the polar regions would grow in a warming climate because we'd see more evaporation of water from the oceans, and that would fall as snow. And that's the backdrop against which we switched from space observations to Earth observations. There were some other stories happening at the same time. There was the ozone hole, for instance. But there was an increasing realization that we needed to monitor our planet and the changes that were happening in our planet. So fast forward, well, at least in the context of cryosphere, that's when Cryosat was designed back in the 1990s, against this backdrop of not believing that climate change was a concern for Earth's ice. And that's simply not true, and been proven not to be true since then. So we know mountain glaciers, for instance. This is Iceland. By the end of the century, Iceland will lose around 3/4 of its ice to melting. And that's happening all around the planet today. And we can see it if you visit the polar regions or alpine regions. You'll have seen the changes over the past 20 years. And lots of people depend upon the water that's melted from mountain glaciers in particular. And that nourishes many, many rivers around our planet. So this is the Danube. It does have some glacial fresh water into it, only 2%. But globally, 25% of the water in rivers is sourced from melting glaciers somewhere or other. And that's a problem because we're expanding the colonization of river basins around our planet because of this abundance of fresh water, but that will be gone by the end of the century. And so the water resources won't be there to sustain the people that are now living and migrating to these parts of our planet. And that's 2 billion people today depend upon water from melting glaciers at some time or other. And that also happens here. 83 million people live in the Danube Basin. And so it's really important that we are aware of the changes that are going to happen into the future. And so we need science to tell us about these things. We can't put too many people dependent upon parts of our planet that won't be able to sustain them in the future. We know about melting glaciers as well. And so Earth's ice is in really cold parts of our planet, right? We thought in the 1990s that it wouldn't be touched by global warming. But in fact, much of it is in contact with the ocean. And we don't need to warm the ocean by a great deal before it starts to melt ice. Every 1 degree centigrade change in ocean temperature melts 10 meters of ice per year somewhere around the planet. And that has a devastating effect on the glaciers that are further inland. They're speeding up and pouring, as a feedback effect, more ice into the oceans. And we've learned all about this, not from visiting these parts of our planet, but from making satellite measurements of our planet in the past 20 to 30 years. And they've become really vital in terms of our understanding of what to expect into the future. And there's the knock-on effects associated with the changes in the planet as well. So we see more disturbed weather patterns around our planet. So this is the UK in 2018. And we don't really expect weather like this to hit the UK, but it does. We see more erratic weather patterns, and we have to prepare for it. And we are prepared for it thanks to the satellite observations and the improved models that we've been able to build on the back of those satellite observations. So this is Crysat, as Simonetta said, really, thankfully, it was rebuilt and relaunched after the first failure, and it got into space in 2010. And it's been an absolute success, a remarkable achievement. It's still in space today, 15 years later, celebrating its 15th anniversary now. It was commissioned for 3.5 years, and it's vastly exceeded all expectations thanks to the precision engineering that was put into building the thing and launching the thing, and then the people keeping it in space. And we have struggled to keep it in space, but we've been able to keep it in space, and it's a vital record for changes in Earth's ice. And we can map all corners of our planet now with this one satellite. And it's an analogue for many other parts of the Earth system, not just climate, but the whole Earth system is monitored. We hear taking the pulse of the planet. This is it. We can measure changes in Antarctica without having to go to Antarctica. And that's really vital as well, because that's an expensive and costly way to carry out climate science. And using space is actually by far the cheapest way to monitor the planet. And so we can now look everywhere around the planet and add up, in this case, how much ice has been lost. And so this is an example of it next to Paris. We're losing 1 trillion tons of ice per year from our planet every year for the past 30 years. And that's coming from melting mountain glaciers. It's coming from melting polar ice in Antarctica and Greenland and speeding up. It's coming from loss of sea ice in the oceans. And it's coming from breaking up of ice shelves around Antarctica. All of these things somehow impact upon us in this room, somehow or other, even though they're happening in remote places. So the first and obvious change is changing in the white colour of the Earth, so the albedo of the planet. We've lost 40% of Arctic sea ice. It's responsible for 1/4 of all actual global warming today because of the positive feedback associated with the loss of the albedo. And so the planet is warmer than it otherwise would be because of the loss of that sea ice. The melting of the ice from Antarctica, in particular, and southern Greenland is disturbing patterns of ocean circulation around the planet, and particularly in the North Atlantic and the subpolar gyre. That's a real concern for lots and lots of different people in Europe and North America. And that's something that we still don't fully understand, and so we have to continue to monitor it. And most obviously, the loss of ice that's on land today causes sea level rise. So over the past 20 or 30 years, we've actually seen quite a modest increase in sea level because of polar ice melting. It's about 2 centimetres. It's not a huge number by most people's standards. But actually, that is a huge number if you spread it all around the world and look at the knock-on effects, and I'll come back to that in a moment. But this is a model of ice into the future in Antarctica. It's one of the biggest glaciers in Antarctica, Thwaites Glacier, and it's predicting how that will change over the next 200 years as a consequence of the warming that we've built into the climate system already today. If you compare the IPCC assessments of polar ice change over time, you can see the progression and the improvement in the models that we're using, that everyone is using to make predictions into the future and to take action. In the 1990s, it was believed, as I said, that Antarctica would contribute negatively to sea level rise, would absorb some sea level rise, and would offset melting in Greenland. And then in the mid-1990s, the contribution was expected to be even higher from Antarctica, the offset, so that there was effectively zero change in sea level. In the 2000s, it was even worse. These models were not right. And even in AR4 in 2007, the picture was completely at odds with what we were seeing in the satellite record. And all of this time, the models were being improved and developed and improved and developed, and people used these models to take action about sea level rise into the future. It's only until AR5 that we got a set of model predictions that lined up with the satellite observations. So it's taken 20 or 30 years to fix climate models to just match the record that we've got from space. And that shows the real vital need for satellite measurements, because we could have just trusted those measurements, those models, should I say, from the 1990s, and forgot about the past 20 or 30 years of climate science. But we haven't done. Climate science is underpinned by Earth observation and improvements to numerical model predictions. And why does that matter? Well, this is the predictions into the future now, and compared to the observations. And we can have confidence in those predictions, not full confidence, because in case of polar ice in Antarctica and Greenland, we're tracking the upper range of the sea level predictions, not the mid-range. And that'll give us an extra 18 centimeters of sea level rise by the end of the century. So does that matter? So I'll tell us a quick story about New York City, Hurricane Sandy, which hit in 2012 and caused quite huge devastation in New York City. It flooded 50 square kilometers of land. It flooded 20,000 homes and 46 people died. So that was a serious incident, and that was when the hurricane sat over the city for a long period of time, and it lowered atmospheric pressure, increased rainfall, increased winds, and passed through several tidal cycles. And you can see the impact of that in the tide gauge record at Battery in western New York City on the Hudson River. So the spike is the flood event at the end of 2012. And that flood event was a once-in-a-thousand-year flood. New York City hadn't prepared for such a flood, and the consequences were devastating. By the end of the century, we're going to see about 80 centimeters of sea level rise. So the Hudson River will actually go up like this. And so we don't need a hurricane to flood New York City. It will flood 2 or 3 times every year just because of progressive sea level rise. So the concern shouldn't be about inundation of small island states. They're important. That's really important. But we should be thinking about coastal cities, and people are thinking about coastal cities. So there's a coastal flood protection plan in New York City that's been enacted. It's a $19 billion plan to protect New York City. That's 3 days of GDP from New York, right? They can afford it. And that plan costs less than the flood caused in terms of losses to the city. So that will happen over the next 10, 20, 30 or 40 years in New York City. We have action going on elsewhere to address other impacts of climate change. We see flood protection schemes in the bottom left, that's West Yorkshire, near where I live. And there's a flood protection scheme going on in the middle from fluvial inundation to protect the city of Leeds from increased rainfall, which we expect as a consequence of climate change. On the top right, we see Bilbao, cooling cities, planting trees. We believe in the science, and so people need to cool their cities. And on the bottom right is a hydropower plant, which is part of the solution. We need to generate energy renewably, and of course we all know that as well. So ESA have driven most of what we've learned about climate science, in fact, through their Earth observation program over the decades. So this is what we've seen from space of the polar regions since the first satellites were launched. So in the 1970s and 80s, we couldn't see very much at all. We didn't have satellites flying over the polar regions. And then, 1980s as well, but then ERS-1, the best ERS, well, we'll have a new ERS. ERS-1 was launched, and we started to see Antarctica and Greenland for the first time, right? And so we're moving into the golden age of Earth observation, where for polar science, but polar science is all science, we had almost complete coverage thanks to Cryosat, launched in 2010, and ISAT, which was launched in the 1990s, in the early 2000s, should I say. We see the whole of the cryosphere, and we've been able to go backwards in time and make use of the early measurements to stitch together a record tracking back for the past 30 or 40 years. In the future, well, today we also have ISAT from NASA. We have CRISTAL, and that's thanks to ESA, commissioning a successor, somehow or other, to Cryosat to keep this continuous record for us all to make use of. And in fact, we had a community activity that we got together, the polar science community, and asked ESA if they could do something about bridging the gap that would exist between Cryosat and CRISTAL, and they responded, right? This was a really good example of the scientific community coming up with concerns and requirements, asking the agency what they could do, and they've struggled really hard to keep Cryosat in space for another 3 or 4 years, and that'll take us up to the launch of CRISTAL. So this is an absolute success story, and it's something that we should really be proud of as Europeans, in fact, for having achieved this. So what I'll say, just a few words. I'm sorry for the lecture on polar science, but it's a good example of the importance of Earth observation. It's climate science is founded on Earth observation. The modelers will tell you it's all in the models, but I've just shown you that the models needed to be fixed, right? And it was the Earth observation that gave us the true record. And we work hand in hand. The IPCC is the interface of climate modelers and climate observations, which are primarily from space. The science is what underpins action by other people or by ourselves, by other people on behalf of us, to address the problems that the planet is facing and to adapt to the world that we're going to be living in the future. That action is actually the green economy that our countries will benefit from in the future. All of those actions are people's jobs, either constructing flood defences or shifting floodplains or planting trees in cities. These are the green economic jobs that will be needed around the world, and hopefully will appear first in Europe thanks to the observations programs that we've led. And Europe is leading the way on Earth observation. It's absolutely true. So I would say that future EO is absolutely essential, and it's really, really important. And I agree with what's said. We should spend more money on Earth observation because it's a huge success. That story that I've just told you about our improved knowledge of the climate system can be told over and over again with different elements of the climate system. So I want to thank everybody in the room who builds the satellites that we collect measurements from and make use of. So that's all I want to say. So thank you very much.
Thank you so much.
Very nice. Yeah, good talk.
Okay.
Very good. And
Thank you.
yeah.
I mean, it was a really nice set of presentations to talk about where we're going hopefully in November, but also in the years to come. We are a bit over schedule, but I would like to give the opportunity for 1 or 2 questions if that's okay, if anyone has any. The other thing I wanted to emphasize again is that Future EO will have an Agora session tomorrow at 3:30, where there will be more discussion about the program. And Digital Twin Earth will also be discussed in more detail on Thursday. So there is an opportunity to also interact with ESA colleagues in the context of those 2 sessions. So I don't see anyone who's raising their hands. Probably people are trying to get to the next session. So with that, I would really like to thank all of our speakers. I appreciate very much that you've shared all of this.